Hi everyone! Before we start our lesson today, I want us to complete a few quick factor and solving problems. So what we need you to do is we need you to pause the video, complete these two problems, and then hit play when you're ready to see the solutions. All right, let's look and see how you did. So we factor the first one into x minus 6, x plus 3, and then we set each one equal to 0 and solve for x. And that gives us the solution x equals -3 and 6. On the second one, we have to make it equal 0 first. So we subtract 10 from both sides. Then I can pull out a GCF of 2. That gives me x squared plus 4x minus 5 equals 0. I can then factor the inside to be x minus 1 times x plus 5. So that gets me completely factored as 2 times x minus 1 times x plus 5 equals 0. I then set each factor equal to 0 and solve for x. Now 2 will never equal to 0, so that only gives me solutions of -5 and 1. Today we're going to be starting Unit 5B. These are the notes for 5B.1. Today we're going to be talking about attributes of polynomial functions and adding, subtracting, and multiplying polynomials. Let's review from Algebra 1 how we classify polynomials. We can classify polynomials by their number of terms and by their degree. Now we want to remember when we classify by terms that terms are separated by addition and subtraction signs. So if we just have one term, we call that a monomial. 2 terms, binomial. 3 terms, trinomial. And then 4 or more terms just gets the blanket term of polynomial. Now, when we classify by degree, that is looking at the highest exponent on your variables. So you look at all your variables and you pick the highest degree. So you pick the biggest exponent, which represents the highest degree of your polynomial. So a degree of 0 is a constant. And you're maybe like, well, I don't ever see x to the 0th, y to the 0th. And that's probably because anything to the 0th power is really 1. So we don't really ever write x to the 0th power or y to the 0th power. Okay, if we do, we can just change that to 1. So when we say degree 0, we're talking about a term that does not have a variable in essence. So a degree 0, that's basically just like a number like 4, 5, 6, whatever. We call that a constant. If it has a degree of 1, we call that linear. Think about y equals mx plus b. The highest exponent there is 1. So if your highest exponent is 1, that is a linear polynomial. If your highest exponent is 2, we call that quadratic. Think about x squared. That is a quadratic equation. If your highest degree is 3, we call that cubic. Again, think about the cubic function, x cubed. If your highest exponent is 4, we call that quartic. If your highest exponent is 5, we call that quintic. And then if your polynomial is 6 or larger, we just call it polynomial of degree blank. So if your biggest exponent is 20, it's going to be polynomial of degree 20. You just fill in with whatever the highest degree is. All right, now we want you to practice what you just learned on the previous slide. So we want you to classify each of these polynomials by degree and term. So hit pause on the video, complete the chart, and then when you're ready to check your answers, hit play, and you can see what we put. All right, welcome back. Let's look at our first one, 61. So to classify that by degree, remember it's the biggest exponent on your variable. Well, I don't have a variable. I mean, I do, but I don't, because really if there is no variable, that's like having x to the 0th power. So x to the 0th power or no variable, that means it's a constant. Now, when we look at terms, there are no addition or subtraction symbols, so that's just one term, so that is a monomial. 3x squared. Well, the biggest exponent is 2 on the variable, so that's a quadratic, but there's still only one term because there's no addition or subtraction. Okay, so monomial. Now, don't be fooled by this third example. Even though it starts out with x squared, your highest exponent is to the 4th. So that makes it quartic. And then when we classify it by terms, there is one term, two terms. So that makes it a binomial. Let's look at the next one. When we classify x plus 3 by degree, the exponent is not written, but if you remember, that's an x to the 1st. So since that's an x to the 1st, it is linear. Now there are two terms. Two terms is a binomial. Now let's look at this example 5. There are 3 variables, but the biggest exponent is 3. So since my biggest exponent is 3, that makes it cubic, and there are 1, 2, 3 terms. So that makes it a trinomial. And then lastly, on this last example, our biggest degree is 5, so that makes it quintic. And then there are 1, 2, 3, 4 terms. So that makes it a polynomial. So that's how we classify by degree and terms. All right, let's look at this slide here. This is really nothing to write because you've already written it down from last class period, but let's go over this and talk about what it means. So we want to start with a review of the fundamental theorem of algebra. The fundamental theorem of algebra tells us two things. It first of all tells us that the roots, like solutions, roots, zeros, x-intercepts, all that good stuff, the roots of polynomial functions are complex numbers. That means that your SRZs can be real, they can be imaginary, or they can be a combination of real and imaginary. Now, the second bullet tells us something super duper duper important, and we'll need it, especially going through the rest of this unit. And what it tells us is that the degree indicates the maximum number of roots. So if you look at the highest degree, that's the maximum numbers of solutions, roots, and zeros that the polynomial has. So if your biggest exponent is 5, then that means your polynomial has a maximum number of 5. That's the most number of SRZs that it can have. So that one is super duper important. You want to remember that for sure. Okay, that is super duper important right there. All right, so just to review the complex number system, please remember your number system is separated into reals versus imaginaries. Imaginaries are obviously when you get a negative underneath the square root, that kind of thing. Those are your imaginaries that we talked about back in Unit 4. Of course, the real number system, that's broken down into your rationals and irrationals. Irrationals are numbers that are like the square root of 7, where you get this decimal that goes on forever, or pi. That's one of those decimals that goes on forever and ever and ever. Now, the rationals are anything that can be written in the form of a ratio of A to B, A over B, okay? So then within the rationals, we break down and we go further, and then there's the subgroup of integers. Integers are your signed numbers that don't have decimals, okay? So like -2, -1, 0, 1, and 2. Then within the integers, we break that down into another subset of whole numbers. Your whole numbers are numbers that start with 0. There is no decimal, and they're strictly positive. Okay? And then lastly, the whole numbers break down into the counting or natural numbers. I've heard it referred to as both counting or natural. So when we start counting, we don't go 0, 1, 2. We start with 1, 2, 3, 4. So that's kind of where they came off with the name of counting numbers. But those are natural numbers. They start at 1. They are whole. We start with 1. They're whole numbers, positive, all that good thing. Okay? So just keep that in mind as we go through this unit. Now, if you have a moment, what you can do is you can plug each of the two equations in and look at their end behavior, the shape of the graph, how many turns it has. Turns are like peaks and valleys, okay? So this would be a chance for you to kind of just like plug in the pink equations and see what you can tell about the end behavior of the graphs, the shape of the graph, how many turns it has. And you can do that for each of the 5 subsets. But we're not going to take the time to do that now. That is something, if you ever have a graphing calculator, you can sit down and look at. On the next slide, I'm going to tell you how to determine that information just by looking at one term. Okay, let's look at how we can determine a polynomial graph's behavior based solely on one term. So, the term we're going to be looking at is the term ax to the nth power. Now, here's what we need you to know. We are assuming that ax to the nth power is the leading term of a polynomial in standard form. Now, if you'll recall, standard form is where we write all the terms of a polynomial from highest exponent to lowest exponent. So the leading term is the term that has the biggest exponent on the variable. Okay, so ax to the nth power. The first thing we want to look at is, what does a tell us? A tells us the right end behavior. A tells us the right end behavior. So is your right end pointed up or is your right end pointed down? So let's think back to a quadratic, because that's what we've most recently studied. If A was positive, that quadratic opened up. So if we just look at the right end behavior, the right end is pointing up. If A was negative, that meant my parabola opened down. But again, just looking at the right end behavior, the right end was pointed down. So if A is positive, your right end is going to be pointing up. If A is negative, your right end is going to be pointing down. Now let's turn our focus to the exponent. If n is even, if that exponent is even, the left is going to be the same as the right end. So again, let's look at x squared, because in x squared, that has an even exponent. So if your exponent is even, your right and left ends are going to be doing the same thing. If n is odd, the left and the right ends are going to be opposite. So let's look at a cubic function. This is a sketch of x cubed. That exponent is odd. So since it's odd, you'll notice that in this one, the right end is up and the left end is down. So if the exponent is odd, the left and right ends do opposite things. Okay? Now, the n tells us one other thing. If we take n minus 1, that tells us the maximum number of turns in the graph. Now you're like, what are turns? Well, turns are like our peaks and our valleys, our mountains and our valleys. A turning point is where our graph will go from increasing to decreasing. Or decreasing, 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 turning point, increasing, increasing, increasing. So our turns are like our peaks and valleys, okay? So if we do n minus 1, that tells us the maximum number of turns that we can have. Now, does that mean it has to have that many? No, but that's just the maximum number. So let's look at a sketch of x to the 4th. If you were to graph x to the 4th, your graph would have a W-shaped appearance. Well, 4 minus 1 is 3, so let's look. There's 1, 2, 3 turns. Okay? So, just by looking at the leading term, we can tell what the right end's doing, we can tell what the left end is going to be doing, and then we can determine the maximum number of turns. Now again, it doesn't have, like x to the 4th, it doesn't have to have 3 turns, but that's just the maximum number that it can have. It could still have 1 or 2 depending on the graph. So, but for x to the 4th, 3 is the most. All right, so we're going to kind of repeat the process we did like we did with classifying polynomials. We want you to pause the video and we want you to complete this chart just by looking at the equations. So we want you to give us the right end, the left end, and the maximum number of turns. Once you've completed this chart, then hit play, and then you can see if you're right. Remember, you're basing this off of that slide that we just looked at. Okay, let's see how you did. So the first equation, our leading term would be 2x cubed. 2x cubed. So for the right end, we're going to look at the a value. Okay, so in this case, my a is positive. So that means my right end is going to be going up. Let's talk about the left end. Well, the left end is based off the n. So my exponent is odd. Odd means opposite. So that means if right end's going up, left end is going down. Now the maximum number of turns is n minus 1. So 3 minus 1 is 2. So this polynomial could have at most 2 turns. All right, look at the next one. My leading term is negative 2x to the 4th. So a is negative, so that means my right end is going down. My left end is based on the exponent. My exponent is even, so that means it's the same. So if right end's going down, left end's going down. Now for the maximum number of turns. The exponent is 4. 4 minus 1 is 3. So this can have, at most, 3 turns. Last example. My leading coefficient is negative 5x to the 5th. So a is negative, so that means my right end is going down. And my left end, well, that's based on the exponent. The exponent is odd, so it's opposite the right end. Opposite of down is up. And then the max number of turns is n minus 1, so that would be 4. Now, let's look at this. They've given us the graph, and they say which is possible for this graph according to end behavior. Well, the first thing I'm going to look at is the right end. The right end is going up, so that means A is positive. So I'm like, well, A is not positive there. A is not positive there. So that drops me from a 1 in 4 chance to a 1 in 2 chance. We've got a 50-50 odd here. Okay, now, so I know the right end is up, so that means A is positive. Then I look at the left end. Well, the left end is going down, so that's opposite. Opposite means I need to have an odd exponent. Well, the biggest exponent here is even, so we can't count him. So that means that D is the only answer left. But let's just double check if this is right. One more thing. Let's look at the turns. If this is right, I'll only have a maximum of 4 turns. So there's 1, 2, 3, 4. I only have 4 turns, so that works. D is my choice. Okay, let's kind of flip the tables here. Instead of us picking a possible equation, we're going to draw a possible function with the given information. Okay, now is this going to be exact and specific and exactly no, because it's just a possible because they didn't give us everything. We can do a sketch, but they didn't give us enough to determine some other pieces. Now, next time in class on day 2, we are actually going to be talking about here's the equation, graph everything you know about it. And it's going to be so precise and so exact, but we don't have that information now. So we're just kind of dipping our toes in the water, getting used to these terminologies, and then on day 2, we're going to take all that information and run with it. So again, it might not be exactly as I do it. You may have a different one, but as long as it meets these qualifications, you're fine. Okay, so we want to draw a possible quartic function with a negative leading coefficient, 2 real roots at the square root of 3 and negative square root of 3, and a y-intercept of 2. So the first thing, and we're going to talk more about this next time, but the first thing you always graph are the roots. Now, the roots, the SRZs, the x-intercepts, whatever you want to call it. Now, the square root of 3 is approximately like 1.7-ish. So we're going to put a dot at 1.7-ish and negative 1.7-ish. So we're going to plot those intercepts first. Okay? Then we are going to plot the y-intercept. The y-intercept is 2. Now we're going to get into end behavior. We're going to get into end behavior. Well, we have a negative leading coefficient. That means that A is negative. So A is negative. So A tells me the right end behavior. So if A is negative, that means my right end is going to go down. Now, the other piece of information it tells me is that my function is a quartic. So that means it's an x to the 4th. Well, that exponent is even. So even exponents tell me that the right and left ends are doing the same thing. So if right end is going down, left end is going down. All right, now the quartic tells us one more thing. Go back to n minus 1. 4 minus 1 is 3. That means we can have a maximum of 3 turns. So as long as you have like 3 turns and you make it so that it goes through the y-intercept as well, you're good. So it might look something like that. See, there's 1, 2, and 3 turns right there. Now you could have put your other 2 turns on the other side, but it needs to look something like that. Now again, don't get stressed. It's just a sketch. Just a sketch. We're going to get into the finer specifics of graphing on day 2. Okay, let's look at the sum and difference of 2 cubes. So you'll want to memorize these formulas, and they're just formulas, guys. It's just something you're going to memorize. It might not make sense to you till later in the unit, but we're going to show you later in the unit how we derive these formulas. But for now, we want you to get comfortable with the formulas. All right, So the first formula we're going to look at is what happens if I have two cubes that are being added together. Well, the first thing you want to do is you want to say, okay, what cubed is going to give me a cubed? Well, a. And what cubed is going to give me b cubed? Well, b. So you want to say, okay, how do I get a cubed? That's a to the third power. How do I get b cubed? Well, that's b to the third power. Now, here's how the formula breaks down. You're simply going to take this a and this b, and you're going to say a plus b. And then in your second parentheses, you're going to take the a and square it. If it's plus, this symbol becomes minus. And then you're going to do a times b, and then plus b squared. Now, the formula is pretty much the same if it's difference. It's just there's a little flip in two signs. So what gives me a cubed? Well, a to the third power. What gives me b cubed? Well, b to the third power. So if this is a cubed minus b cubed, then my first parentheses is going to be a minus b this time. See, up here it was a cubed plus b cubed, so it was a plus b. But here, on the second formula, it's a cubed minus b cubed, so it's going to be a minus b. And then your second parentheses is going to be a trinomial. And what you're going to do is you're going to do, for the first term, you're going to do a squared. And then if this is minus, you're going to make this sign a plus. Then your middle term will be a times b. And then your last term will be b squared. So basically, they're the same formula with two little different sign changes, okay? So same formula, but if it's a cubed plus b cubed, it's going to be plus, then minus. But, so like here, it'll be plus, and then minus, okay? But if it's a cubed minus b cubed, it's going to be minus, and then plus. Other than that, they're the same formula. Now, I do want to tell you something else, okay? These trinomials that are tacked on at the end, if you've done it right, they will never, ever, ever factor any further. They will never factor any further. So that a squared minus ab plus b squared and a squared plus ab plus b squared, okay? Those trinomials will never, ever, ever factor any further. All right, let's try a few. So x cubed plus 8. Now, you want to break it down so that you know what a is and what b is. So what cubed gives me x cubed? Well, x. And what cubed gives me 8? 2. So x to the third power gives me x cubed. And 2 to the third power gives me 8. So this x and that 2, those are going to be my a and b. So if you remember the formula, if it's a cubed, sorry, that 3 did not come out right, a cubed plus b cubed, then the formula was a plus b times a squared minus ab plus b squared. So that's why it is so important to identify, because your b is not 8, your b is 2. So the a is what cubed gives me the first term, and the b is what cubed gives me the 8, or the second term. So a is x and b is 2. Now I'm ready to write my formula. Well, it says a plus b, so that's going to be x plus 2. Now, for the next parentheses, it says I take a and square it. Well, a is x, so that's x squared. It's plus, so it's minus. then it's a times b, 2x, and then it's plus b squared, so 2 squared is 4. And that's how you get the trinomial. Okay, let's try another. So 64 is a perfect cube, y is a perfect cube, 27, so we're all good. Everything's a perfect cube. Okay, so what cubed gives me 64y cubed? Well, that's going to be 4y. 4 times 4 times 4, 64. Y times y times y, y cubed. And 3 cubed gives me 27. So that's going to be 4y quantity cubed minus 3 cubed. So there's my A and there's my B. Now remember that the difference of 2 cubes is the same, except this becomes minus and that becomes plus. But the formula itself is virtually the same with the exception of the signs. So if it's A cubed minus B cubed, then we're going to do A minus B. So that's going to give me 4y minus 3. Then for the trinomial, I'm going to do a squared. So 4y times 4y is 16y. It's minus, so my next sign is a plus. And then 4y times 3 is 12y. And then plus b squared, which is 3 squared, which is 9. Okay? All right, let's do the last one. Well, 4 and 500 are not perfect cubes. Nothing times itself 3 times will give me 4 or 500. So what I'm going to do first is I'm going to factor that 4 out. Then I'm going to do difference of cubes on the inside. So what cubed gives me x cubed? Well, x. And what cubed gives me 125? 5. So that is going to be, I apologize, I just wrote over my work here. So that's, now don't forget the 4. The 4 is quintessential. You got to keep it. That's your GCF. But inside, that's going to break down into x cubed minus 5 cubed. Well, that's my A. That's my B. Okay? So that gives me 4. And then my first parentheses is going to be x minus 5. And then my trinomial is going to be a squared, which is x squared. That's minus, so it's plus. A times b is 5x plus b squared, which is 25. And that's how you factor sum and difference of 2 cubes. Okay, I want you to pause the video and try these 3 problems on your own. You've done this before in Algebra 1. We've done it in each of our units practically. So basically, we're just adding and subtracting and multiplying polynomials. This is stuff you've done before. So I want you to pause the video, and when you're ready to check your work, hit play. Okay, let's see how we did here. Well, on the first one, I have like terms of 6x squared and 3x squared. And then I have 8x and minus 9x. And then I have minus 2 plus minus, or negative 2, excuse me, plus negative 4. So all I do is, since it's addition, is combine like terms, and I end up with 9x squared minus x minus 6. Now, let's look at the second one. This time it's subtraction. Now, always, 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 when it's subtraction, you change it to plus, and then you change the sign of everything inside. And then it's just a matter of combine like terms. Negative x squared plus 2x squared. Negative 10x plus negative 3x. And lastly, 7 plus 1. And you come up with x squared minus 13x plus 8. Now the last one, you're multiplying a binomial times a trinomial. So you can do double distribution and then combine like terms, or you can do a box and then combine like terms. Either way, you will end up with the answer 2x cubed plus 7x plus, or excuse me, 7x squared plus 4x plus 32. So 2x cubed plus 7x squared plus 4x minus 32. Okay, we're going to take a concept you learned to do in Algebra 1 and put a little twist on it and show you how we can use that concept to help us in Algebra 2. So in Algebra 1, you were given a table of values and you were asked to determine, is this a linear function? Is it a linear function? And you did the change in y's versus the change in x's, and if they were all, the change in y over the change in x was the same for every set of points, then it was linear. We're going to use that idea, though, to help us determine degree. Okay, so we're going to use that to help us determine degree. Now, this trick only works if your x's increase by 1. If they increase by anything else, you can't really use this. But if your x's increase by 1, you can use this concept to help you determine, is it a linear, is it a quadratic, cubic, quartic, whatever. Okay, so the first thing you want to verify is, yes, all of my x's increase by 1. We're good there. Now we're going to look at the y's. Well, to go from -1 to -7, that's a difference of 6. So that's a subtraction of 6. -7 to -3, that's a increase of 4. -3 to 5, that's an increase of 8. 5 to 11, that's an increase of 6. 11 to 9 is a decrease of 2. And 9 to -7 is a decrease of 16. Now, if these y changes were all the same, then we would say it would be linear. Okay? But they're not the same, so it's not linear. So now let's go and look at the second level differences. So -6 to 4, that is an increase of 10. 4 to 8 is an increase of 4. 8 to 6 is a decrease of 2. 6 to -2 is a decrease of 8. And -2 to -16 is a decrease of 14. Now, if the second level differences, if these numbers, the 10, the 4, the -2, -8, and -14, if they were all the same, then we'd say, okay, well, it's a quadratic. But second level differences are not the same in this one. So let's go out another level. 10 to 4 is a decrease in 6. 4 to -2, a decrease in 6. -2 to -8, decrease of 6. And -8 to -14 is a decrease of 6. So, since the third level differences are the same, we can say that that function is a cubic. So this would be n equals 1, this would be n equals 2, and this would be n equals 3. So you can use your differences to help you determine the degree. So since third level differences are the same, we already said this, but it is a cubic polynomial. Okay, let's have you try it. So hit pause, determine the degree, and when you're ready to check your work, hit play. Okay, let's see how you did. Fourth level. You had to go out to the fourth level to get the differences to be the same. So this is a quartic polynomial. All right, so that is it. That is it. So this concludes our lesson. Your homework is worksheet 5B.1. And that's it. So just make sure you get your homework done. Please be safe. Wash those hands. Social distance. Make good choices, guys. Please stay healthy and have a good one. And we'll see you back next time. Bye.